Alright, hi everyone. So for this question, it says that by examining the potential maps for NH₃, NH₄+, and NH₂-, we can see that an atom with a formal charge does not always have a higher or lower electron density than the atoms in the molecule with no formal charges. And here we're given a potential map for each molecule listed. So part 1 is asking us which atom carries the formal negative charge in NH₂-, and part 2 is asking us which atom has the greater electron density in NH₂-. So for part 1, let's begin by drawing our Lewis structure for NH₂-, right? And to do that, recall that we have to first determine the number of valence electrons in our formula. And we do that by adding up the valence electrons for each individual atom. So here we're going to have one nitrogen atom, which has 5 valence electrons, and we have 2 hydrogen atoms, each with 1 valence electron each. So that's going to be 5 plus 2 is equal to 7. But because we have a negative charge, we have to add 1 more electron. So that's a total of 8. So now, in order to draw out our Lewis structure, what we do first is we draw the atom with the highest bond preference in the middle, which in this case is going to be nitrogen. And we propose a sigma bond framework. And we do that by surrounding our nitrogen in the center with the remaining 2 atoms, which in this case are hydrogen, and we propose a single bond to each. Right, so we have a single bond for each. And so that leaves us with a total of 4 electrons remaining, right? Because we created 2 sigma bonds, each with 2 electrons. So it's a total of, 4. And so now what we do is we complete our octet for our nitrogen using our remaining lone pairs of electrons. So nitrogen is missing 4 electrons for the octet, so we can go ahead and add 2 lone pairs of electrons with our remaining valence electrons. So from here, we can go ahead and determine our formal charge, right? And formal charge I'm going to abbreviate as FC. And our FC is going to be equal to our total number of valence electrons minus the total number of non-bonding electrons, or NB for short on the screen here, minus the number of bonding electrons divided by 2. So if we calculate our formal charge for hydrogen, that's going to be 1 valence electron for hydrogen minus 0 non-bonding electrons because we have 0 lone pairs minus our 2 bonding electrons from our sigma bond divided by the number 2. So that leaves us with 1 minus 1 when we simplify, which equals 0. Now up next is nitrogen, right, which has 5 valence electrons minus 4 non-bonding electrons because we have 2 lone pairs on nitrogen with 2 electrons each, right? So that's a total of 4 minus 4 bonding electrons because we have 2 sigma bonds, each with 2 electrons as well. So that's 4 bonding electrons divided by 2. And that leaves us with 5 minus 4 minus 2, which leaves us with a formal charge of minus 1. So according to this math, right, our nitrogen is going to have the formal charge of -1. So that is going to be our answer for part 1. And now, for part 2, to figure out the electron density distribution in NH₂-, let's look at the potential map that we're given in the question, right? Which is going to be on the right side over here. And what I want to bring to your attention is that our nitrogen is surrounded by this bright red area, right? And recall that in a potential map, red areas correspond to areas with the most negative potential, right? And our most negative potential equals our greater electron density. So because our nitrogen is surrounded by this red area, we can tell that it's going to have the most negative potential and therefore the greatest electron density. So the answer for part 2 is also going to be nitrogen. And your answer here is going to correspond to option B in the multiple choice. So this is going to be your final answer, right? And for NH₂-, our nitrogen not only has the formal charge of -1, it also has the greatest electron density according to our potential map. So with that being said, thank you very much for watching, and I hope you found this helpful.